We are learning motion in one dimension, and today we will learn about acceleration and retardation. Let us start understanding acceleration. Let's consider the motion in a straight line path, like you can see a car traveling on a straight line path. Now here there is no change in direction, right, of motion, and change in velocity is also because of change in speed. Now let me explain to you over here. The car initially has started with a speed of 0 km per hour at 0 second. In 3 seconds it reaches the speed of 15 km per hour, and in 6 seconds 30 km per hour, and 9 seconds 45 km per hour. So what do you notice here? What is happening? There is increase, right? The velocity of body increases with time. 0 to 3 seconds 15 km per hour, 3 to 6 seconds 30 km per hour, and in 9 seconds it reaches the speed of 45 km per hour. So what is happening here? The velocity of a body is increasing with time. So this is what you have to keep in your mind. The velocity of a body is increasing with time. Let's see what is acceleration. It is the rate of change of velocity with time. Acceleration is the rate of change of velocity with time. Let's understand about acceleration. More about acceleration. We can find acceleration by dividing change in velocity by time interval, or we can say that acceleration is the ratio of change in velocity and time interval. What about unit of acceleration? It can be found by dividing unit of velocity and unit of time. Now you have learned that the SI unit of velocity is meter per second, right? I hope you remember this. And the SI unit of time is second. So when we just replace the value in unit of acceleration, so what happens? The SI unit of acceleration is meter per second, right? That's the unit of velocity, divided by second, that is the unit of time. And so we write this ratio as meter second to the power minus 2, okay, ms minus 2. That is how we represent the unit of acceleration. And the CGS unit of acceleration is centimeter second to the power minus 2. Okay, I hope you have understood till here. So centimeter second to the power minus 2 is the CGS unit, and meter per second minus 2 is the SI unit of acceleration. Now let's understand some relation for acceleration. Let's say that there is a girl who is riding a bicycle in a straight path. Initial velocity that she takes is represented by small letter u. The initial velocity mostly it is 0. Okay, 0 second, and she covers 0 meter. That's the initial velocity represented by lowercase u. Now after some time interval, what's happening? The velocity has changed, right? It is no more 0 seconds, or it is no more 0 meter that she has covered. She's not standing in one place, keeping her bicycle in one place. Now the time that she has covered is 1 minute or 60 seconds. And what about the distance she covered, or the velocity? The distance she covered is 500 meters, half a kilometer, right? Half a kilometer. Let us say that her velocity now is, she's riding the bicycle at 10 km per hour, right? Do you see that the velocity has changed from the initial to the time when she reaches 500 meter? Now let's see she goes further. Let's understand when she goes further. Now you have to remember that the initial velocity is represented by lowercase u, and time interval is represented by lowercase t. Now she has bicycled 5 minutes now. Okay, she has bicycled 5 minutes, and in 5 minutes now she has covered, let's say, a distance of 1500 meters or 1.5 kilometer, and her velocity is 7 kilometer per hour. Do you see there is change in the velocity, right, in time interval? Now from here, the maximum acceleration that she takes is 10 kilometer per hour, right? This is the maximum acceleration, and this maximum acceleration is what? This is known as final velocity, and final velocity is represented by lowercase v. So three very important things you have to understand here: initial velocity represented by lowercase u, time interval represented by lowercase t, and final velocity is what? The maximum acceleration represented by lowercase v. Let's understand it much further. Now, what's the change in velocity? Right, this is how we find the change in velocity. Final velocity minus the initial velocity. Okay, final velocity minus the initial velocity, and time taken is equal to t, lowercase t. I hope you have understood till here. And therefore acceleration, which is represented by lowercase a, acceleration can be calculated using this formula: change in velocity divided by time taken. And what is change in velocity? V minus u, right? So acceleration a is equal to v minus u divided by t. Now if we have to find final velocity, then we'll use the formula v is equal to u plus at, where v represents, lowercase v represents final velocity, right? That is what the lowercase v represents. The lowercase u represents the initial velocity, right? I hope you are understanding it. And the lowercase a represents the acceleration, okay? And the lowercase t, I'm sure you know what it represents, right? It represents time taken. So this is the formula to find final velocity, and the one that you see before this, I mean above this on your screen, that's the formula to find acceleration. Now suppose if final velocity is greater than initial velocity, then what? Then acceleration is positive, okay? But if final velocity is lesser than the initial velocity, then acceleration is negative. Now this negative acceleration is retardation. A is retardation when it is negative and when final velocity is less than initial velocity. And acceleration is a vector quantity. It is represented by the symbol A with the arrow sign on top of it. Now let's see uniform acceleration. Let's say a stone is falling straight down, okay, under gravity, 0 meter in 0 second, that is the initial. Okay, what is happening here? The stone is falling down under gravity. Now in 1 second the stone has traveled 5 meters. Okay, in 1 second the stone has traveled 5 meters. We are trying to understand, I am using the illustration of the motion of a body under gravity. Okay, when you throw or if you drop a stone, it will fall downwards. In 1 second the velocity is 5 meters per second, right? And in 2 seconds it will keep on increasing because of gravity. In 2 seconds it is 10 meters per second, and in 3 seconds it is 15 meters per second. Now what you notice here is that there is equal time interval, right? That is 1 second. The acceleration is said to be uniform or constant when equal changes in velocity take place in equal intervals of time. Now let us understand about variable acceleration. There is a person who is riding a motorbike on a straight path, on a straight line we can say, and this person has been traveling at 60 km per hour. Now when he reaches the market, he has to slow down his motorbike, and he is moving at 20 km per hour. And after he crosses the market area, the motorcyclist increases his acceleration and starts traveling at 50 km per hour. You see the time here, 5 minutes, 10 minutes and 15 minutes. These are the times in which he changes his acceleration. Right? Now velocity is not same. You see in the first instance 60 km per hour, second instance 20 and third 50. Velocity is not same. But what is same here? Same intervals of time. At 5 minutes he was traveling at 60 km, then 10 minutes, then 15 minutes. You see that the time interval is same. 5 minutes is the difference. But what is not same? Velocity is not same. And so if change in velocity is not same, like in the illustration that I've showed you, if change in velocity is not same in the same intervals of time, then the acceleration is said to be variable. This is what is variable acceleration. Now let's say a body falls freely under gravity. Okay, if a body is falling freely under gravity, we'll understand about acceleration due to gravity. A body has been falling freely, okay, because of gravity. Now when a body freely falls under gravity, the acceleration that is produced in the body, right, it is freely falling because of gravity. The acceleration produced in the body because of Earth's gravitational attraction is called as acceleration due to gravity. So the acceleration caused because of gravity is known as acceleration due to gravity. Now mostly or generally acceleration due to gravity is denoted by g. Now let's say when the body falls down, the acceleration will be positive g, okay, plus g, positive g. When the body falls down, the acceleration is plus g or positive g. Now when the body moves vertically upwards against the gravity, okay, when the body moves vertically upwards, we can say against the gravity, what happens? The velocity decreases, right? The velocity will decrease when it is moving away from the gravity, and so the velocity decreases with time, and the acceleration is denoted by minus g or negative g, which is termed as retardation, okay, which is termed as retardation. Now when the body falls down, what happens to the velocity? It will increase, but when the body moves upwards, the velocity decreases. When the body falls down freely because of gravity, it is called as acceleration due to gravity, which is plus g, and when it is moving against gravity, it is known as retardation, right? Like you can see, I'm trying to explain to you that velocity increases when a body is freely falling because of gravity. Now remember that the value of g, okay, the value of g does not depend on the mass of the body, especially in vacuum. You know, if you drop two objects or two stones with different mass from the same height, it will reach the floor at the same time, okay, it will reach the floor at the same time or simultaneously, right? I hope you understand this. But this will happen in an environment where there is no air, no friction, okay, in vacuum. In vacuum there is no effect of friction and buoyancy due to air, right? So what will happen is different mass does not affect acceleration due to gravity. The average value of gravity is 9.8, or the average value of acceleration due to gravity is 9.8 meter per second square, or we can say it as 10 meter per second square. So this is the average value of acceleration due to gravity. Now value of g is not same everywhere. Okay, value of g varies from place to place. And value of g is more, maximum or greater at the poles, right? The North Pole and South Pole, value of g will be greater. Now there's one more thing I want to tell you, that the value of g is minimum. Okay, the value of g is minimum at the equator. Remember these points. All right, keep learning and keep studying. I hope you have understood this, what we have learned till now.